Okay? 네, 안녕하세요. 반갑습니다. 제 아내는 한국 사람이기 때문에 한국에 많이 와봤지만 크립토 컨퍼런스는 처음입니다. Okay, that's all my Korean. I can make it. Yeah. Thank you. I was practicing this so many times so that I got lost in the subway, but I'm so glad, I made it. So hope it was worth it. Okay. So today, I'm going to talk about topic is ENS for your community, and how many people are actually hacking today? Okay, yeah. If you are hacking, probably they are hacking. Okay, that's good because I saw so I didn't put code. So this is more of like I meant it's so non-technical. But if someone decided to hack suddenly, like after my talk, and if you wanna, get to know more detail, feel free to grab me or like I have some pointers to some of the repos. Yeah. Okay. And today, so okay, actually, who has ENS name? Okay, that's great. Thank you. Who has subdomains? Okay, 3-4 people. Yeah, so ENS subname, or we used to call like subdomains, been there. Oh, it's there. Okay, great. Thank you. Been there since it launched back in 2017, but it's kind of less utilized, but we made some changes to make it more usable. So today I'm going through like 4 use cases so that maybe for your next project, you could use some aspect of it. And so first, what is ENS subnames is that, so this is actually ENS name that as you know, like Ethereum address is kind of hexadecimal, not user-friendly, so you can provide human readable name like matoken.is. So I, in fact, have this so-called ENS card, which means POAP NFT badges. So if you tap with NFC card, we can give the card to say badges to say we met together. So if you're interested, just come up to talk to me and then tap this. And also, but this is a subname that if you can see, Makoto.argent.xyz. So this is one of the wallet. Does anyone know Argent? Okay, a couple of people. So Argent is one of the first wallet who decided to issue subname when they create the wallet. One of the, I think, onboarding issue is like when people create wallet for the first time, they have no crypto asset, so they had to send somewhere, but they don't really know where to send to. So it was a great UX improvement that Argent decided to issue subname for each user who onboarded. That was great. And another thing about subname is like, so to register .eth name, you need to kind of pay $5 mostly annual registration fee. That's mostly to prevent people from like kind of squatting. But once you own it, to issue subnames on the name you own, it doesn't require any registration fee. And if as long as you have that name, you can issue, anyone can issue it. And that was a great way to onboard, as I said. A few things you might not know is .eth name is NFT, but subnames are not. And I will describe the reason later. And this is not just for subname, but like most ENS is known for name service on Ethereum, so you have to pay gas. So for that reasons, Argent now doesn't issue subnames because back into 2020, when like DeFi summer kicked off, people start seeing like 100 Gwei, and it's getting too expensive to issue subnames. Okay, so I'm gonna, NFT. Oh yeah, so now I'm going to talk about one of a few ways to issue subnames, and first is called subnames as NFT. And so problem recap, the reason why it's not NFT comes down to the architecture of ENS. In ENS, it's have the hierarchical architecture. So like if you own the name and if you subname, the parent can always override their ownership. So if subname is NFT, parent domain owner can still override, which kind of defeats the purpose of like NFT being the kind of transferable. So that's why by default it's not NFT. And as you also know that ENS.ETH name has expiration, and if parents get expired, children get expired too. And to overcome that problem, we spent like last 2-3 years to come up with something called name wrapper. And the name wrapper, as the name suggests, it wraps existing names. So you can wrap .eth name or subnames or even like a non-ETH name. Another thing you might not know is like you can actually import DNS names such as .com, .io, .xyz, and they are not NFT, but you can actually make it NFT. Wrapping DNS imported name has a bit limitation, the fact that you actually, if you re-import it, you can overwrite the ownership, but at least you can kind of see if you wrap it in NFT, you can see it in your wallet. So it has some utilities. And also the reason you wrap is the fact that we add a few permission controls, which we don't have. And the most important bit is, so we call it fuses. The idea is like fuses, once you burn it, you cannot revoke it. So like these what we call fuses. And one thing you need to implement is that basically the fact that parent can overrule children. So first fuse you need to burn is that control, you need to burn it. Then there's tons of ways to control how your name can be controlled, and there's like 5 or 6 of them. And by using them, you can create some certain combination of, like, if you can extend expiry and the parent cannot control, you can, by binding these two, it allows you to kind of sell as permanent root names. And also, if you burn these 4 combinations of can extend expiry, parent cannot control, cannot unwrap, and cannot create subdomains, then you can kind of sell permanent names but prevent them from creating their own subnames if you want to kind of have a limited issues of subdomains. And also, parent cannot, if you, by burning parent cannot control, you can also, you could write a contract to let out the names and the stuff. There's quite complex, and to be really honest, like I think I have 100% grasp the whole capability of it, and also it has a lot of kind of side effect of if you burn this happens. So there's a thing called fuse book, which will allow you to kind of interactively play with the various fuse conditions. So if you only burning this fuse, you can now burn this kind of fuse. You can experiment interactively. So that's the first one. And the other example I explained, you need to kind of be able to code by yourself, but this wrapped names, you should be able to control everything using our app site called app.ens.domain. So even though it's one of the most complex example, actually you can do it in no code. So if you want to try out, go to our site and try to burn a couple of names, fuses. And the next one is I coined the term called digital twins. And the use case is that who owns NFTs? Okay. Yeah, so, and maybe some people may be into, like once they issue NFTs and they try to craft a community around it. And a couple of the requests we received is like, can you create ENS subnames for each these NFT owners? And can you also transition the ownership dynamically, that if you have a punks and if you, person A has punks, and if you transfer to person B, can you make subnames so that it can transition? And the ownership as the NFT ownership moves. And it is actually possible using the so-called ENSIP10 wildcard. This one, the idea is that it's all kind of implemented at the client level, that if subdomains such as, in this example, it says 1.doodle.is, doesn't exist on a smart ENS contract, the client asked to its parents, doodle.is, to say, do you know anything about this subdomain? And by using this wildcard convention, you can actually create a contract which dynamically looks into the ownership of this, for example, doodle NFT. And if it's owned by Doodle NFT, you can actually say one's ownership does belong to Doodle. So this kind of stuff, we knew it's possible to do, but we never had time to implement. But I think great things about open protocol is like all the ENS contract is open source, you can look into it. So one of the community member called Rafi.is, he's actually one of the great contributor to the ecosystem, and he gave some big contribution, but he played with the idea and he created something called NFT-owner.is, which allows you to kind of wrap names into, so not wrapping, but basically associated this gasless, by utilizing this model, it has something like, for example, if you want to give subname for Moonbird, in this example, it says like moo331.nft-owner.is. And yeah, then beauty is that's automatically assigned. So like when owner of the parent NFT changes, it doesn't require for you to pay any gas, which is kind of interesting model. And the third model is called gasless. And yeah, part of the reason why Argent stopped issuing subdomain is the fact that gas is too expensive. And that's very shame. And we've been working on another specification called EIP 3668, scale off-chain data retrieval, which is often used in combination with the wildcard example I just described. Let's say I have a token, and if you want to issue subdomain a.matoken.is for free, first, if it doesn't exist on Ethereum smart contract, it goes to the parent, matoken.is, to say, hey, do you know anything about it? Then you can write a smart contract which get the data from something called gateway service. And instead of like previous example, it was checking on other smart contract L1, you can actually fetch the data from this gateway service, which is just like a web services and from off-chain. And I think I described, yeah, I just oversimplified all the technical detail, but the intuition is that like basically ENS itself has been there since 2017 when gas price is not so expensive. So if you used to put everything in on chain, but something like NFT people knows like NFT ownership is on chain, but all the metadata is usually off chain, such as like in OpenSea's database or some like IPFS or Arviv. So the intuition is so that like, yeah, we allow you to specify NFT metadata through this gateway service. And so by doing that, one of the example is Coinbase. Coinbase issued subdomain under the name called cb.id. So if this is example of their Chrome extension, that if you get, in my case, I had Inoue Makoto.cb.id, and if I put all their profiles are all saved into their database, but you can also reference from our website, app.ens.domains, because it's proxy through this gateway service. And I think they have a couple million usernames and the subdomains, and it's all free. So it's already out there. And also another example is when I say off-chain, it can be some random database, but it can also be other chains. So does anyone know who has Lens profile? Okay, about 30%. No, less, probably 10%. Yeah. So Lens is a kind of social network built on Polygon, and Polygon is another EVM-based chain. And so if you have Lens profile, like such as Stani.lens, it's actually proxies through this framework I mentioned. I think I didn't mention the framework name. It's called CCIP read. And so if you have Stani.lens, you can also proxy through gateway under the name of Stani.lens.xyz. That's kind of another use case to bring different name service proxies through ENS. And one thing I want to mention is like this is good and bad. That like I guess off-chain it's gasless, but at the same time, a couple of things like if you have it in the data is in a normal database, you kind of have to trust gateway as well as the data registry. And it might be okay for Coinbase because they are kind of custodial. But if you want to be more purely decentralized, you may not want to have too much kind of centralized solution. And we are working on something called L2 resolver. And the difference between off-chain resolver and the L2 resolver is off-chain resolver, you have to trust the gateway service as well as the data source, whereas L2, I don't know how many people knows how L2 works, but one of the stuff to differentiate L2 or so-called rollup from other side chain which has bridges is that they basically secure the security of the L2 to L1 by kind of batch committing the L2 state into L1. And this is usually not exposed to end users because people don't really use these features, but we actually kind of depend on these features so that we can write a solution to check. So when you ask data from gateway service, not only asking for data, we can get the proof from the L2. There's something called storage proof. ETH get proof is a kind of RPC code. You can call to the many chains, and you can get the proof, which includes a kind of storage proof, which is a kind of Markov tree. By doing that, you can write a L1 contract which checks if the L2 state is in the list of the L1, the contract committed on L1. Then later, if you have that with using that and the Markov tree, you can actually check the storage position of the certain L2 on L1. By doing that, off-chain these gateway, you still have to depend on gateway service, and but one thing gateway service can do is kind of stop responding the data, but they can never manipulate the data. If they manipulate the data, that we can write a one contract to say the data is invalid. So this one, we already have a couple of prototypes, and yeah, we are trying to work on it so that it's available sometimes either this year or early next year. But currently, the L2 solution isn't really available. So if you have next project, for example, if you have a next event, and if you want to issue subdomain to all your conference users, you can create this kind of off-chain solution. And we have my colleague Greg created a demo pack to kind of show the power of kind of gasless subname creation using this repo. So if you can just fork this one, you can probably create one. And that's about it. Thank you very much.